Hello and welcome to a slightly different video. Today I'm looking at a breakfast warm-up for the higher tier. So tomorrow morning all students across the country are going to be sitting their GCSE Paper 2 calculator paper. This is designed as a breakfast warm-up. It is not to replace any warm-up that you would do face-to-face with your maths teacher. So please, if you're planning to attend a session, do not do this. This is designed for the students that aren't able to or don't really feel comfortable. My school are doing it as a large group, so it's for those students that don't feel comfortable to be in a large room with a lot of people, or people that aren't able to get into school early. You can do this on the bus, just to get your mind fresh and ready for the paper, and just give you a few tips and calculator techniques. I've stolen this from Resourceaholic. It's a fantastic website, absolutely chock-a-blocked, full with maths revision resources, so please do check them out. I will put their link to their website in my chat for this, but we'll kick off. So I'm going to do this at a row at a time. We'll see how I get on. I haven't done this before, so we'll wish me the best of luck. Right, question 1, solve 9x squared is equal to 49. So let me just make this slightly bigger so I've got a little bit of working room. Okay, so I'm going to divide both sides by 9 first of all, and that's going to give me x squared is going to be equal to 49 over 9. So my final step then is to square root both sides. When I square root both sides, technically speaking, I'm going to have a plus or minus version of the square root of 49 over 9, which is going to be plus or minus 7 over 3. Okay, for the second one along then, factorize. So I'm going to be looking at putting this into 2 brackets. In theory, I'm actually going to do this as 2 sets, and only 1 set is going to work out. So I can either make 6x squared by having a 6x and an x, or by having a 3x and a 2x. And then my second coefficient of 5, I can only make it with a 5 and a 1, so I need a combination of placing that in that will make 17x. So if I put the 5 there, that would give me 30 and 1, so that's not going to work. So if I look at the other one, if I put the 5 there, that would give me 15 plus 2, so it's got to be there and there. So plus, so that's the version that I'm after. Okay, third one along. So the area of triangle ABC is 15 centimeters. AB is 5 centimeters, and BC is 7 centimeters. Find the size of the acute angle to the nearest degree. Okay, so for this, I'm going to assume, and it makes perfect sense actually, because if you think if it was a right angle triangle, the area would be 14.5, so it's got to be smaller than that. So the acute angle I'm going to assume is here, and I've got a length of 7 and a length of 5. I'm going to call that theta for now, and I know that the area is going to be 15 centimeters squared. So let's just see whether I've got enough room for this. So 15 is going to be equal to a half AB sine C. So if I try and rearrange that now, I'm going to get that sine C is going to be equal to 15 times 2 divided by AB. So if I substitute in my values, then I'm actually going to go straight to the inverse sine version. So I'm going to go sine to the minus 1 of 15 times by 2, so 30, over 5 times by 7 over 35. So let's see. Shift sign, and I'm looking at my fraction button, and I want to go 30 over 35, and that's going to give me 58.9, which is an acute angle. So is the acute angle 58.9, well 59.0 to 1 significant to 1 decimal place to 1 dp. Okay, so we've got find the next 2 terms of Fibonacci sequence. So we're adding the previous 2 terms to get the next term. So if you see 2a plus 2a is 4a, and then plus b would be 4b. So the next term is going to be found by 4a plus 2a, so that would be 6a, and 4b plus 4b, so plus 8b would be my next term. And then my next term is going to be this one plus this one, so it's going to be 6a plus 4a, which would be 10a, and then it's going to be 8b plus 4b, which would be 12b. So those are my next two terms. Okay, so where does the line y is equal to 4x over 5 plus 8 cross the x-axis? So where does it cross the x-axis? It crosses the x-axis when y is equal to 0. So in effect, we're substituting in 0 into this equation. So rather than just substituting it in, I'm going to rearrange slightly as well. So I'm going to say that 4x over 5 is going to be equal to minus 8. So then if I rearrange that, x is going to be equal to minus 8 times by 5 divided by 4. 8 divided by 4 is 2, so it's going to be minus 10. So minus 10. 0 is where it would cross the y-axis. Okay, so my second row. Find the coordinate of the point where y is equal to 3x and x squared plus y squared is equal to 40 intersect. So nice question. We're looking really at solving these simultaneous equations. So I'm going to substitute in, instead of y, I'm going to substitute in 3x. So if I write that as x squared plus y squared, which now becomes 9x squared, is equal to 40. So 10x squared is equal to 40. So x squared would be equal to 4. So x is going to be equal to plus or minus 2. So when x is equal to 2, y would be equal to 3 lots of that, so would be 6. And when x is minus 2, y would be 3 times that, so minus 6. So those are my 2 points of intersection. Okay, what circle theorem is this referring to? So we've got a 60-degree angle here, and we've got this angle here, so that is going to be the alternate segment theorem. Okay, and the next one, so x of n plus 1 is equal to 2xn minus 6. If x1 is 3, find x4. So we've kind of got to go down this process. I'm going to use my calculator for it. So calc. So I'm going to put 3 in as my first value. So 3 equals. I'm then going to use my iterative formula. I'm going to say 2 times by the answer that I last had, minus 6. So every time I press equals, it will give me my next value. So x2, x3, and x4 are the ones that I want. So x2 is going to be equal to 0. x3 is going to be equal to minus 6. So, and x4 is going to be equal to minus 18. Right. Two statues are similar in shape. One statue is twice the height of the other. The smaller statue has a mass of 0.6 tons. Work out the mass of the larger statue. So for this, I'm going to be looking at the scale factor. So the scale factor between the lengths, so I'm going to call that SFL, is going to be equal to 2 because the larger one is twice the smaller one. So the scale factor for volume is going to be equal to 2 cubed. So the mass of the larger statue is going to be 0.6 times by 8, which is going to give me 0.6 times by 8. That's a decimal, 4.8 tons. Okay, and final one on this row. So x is equal to 12 centimeters to the nearest centimeter. Y is equal to 16.25 to 2 decimal places. Work out the maximum value of y divided by x. Round your answer to 3 significant figures. So we want the maximum value, so we want y, the upper bound of y divided by the lower bound of x. So that's going to be the upper bound of y. If that's to the nearest centimeter, that's going to be 12.5. and the lower bound of, I've done that the wrong way around, let's try that again. Same figure though, 12.5 as my lower bound. So let's start that again. So to correct to 2 decimal places, so the maximum that could be would be 16.255, and the minimum that x could be would be 11.5. So 16.255 divided by 11.5. So we get a maximum value of, I'm going to write it to more accurately than I need to, and then I'm going to round. So I've got 1.41347 ... So to 3 significant figures, that's going to be 1.41 centimeters. Just checking out my unit. Okay, so third row. So Abby and Brenda's ages are in the ratio of 4 to 5. In 9 years' time, their ages will be in the ratio of 7 to 8. How old is Abby now? So I've got 2 options really for this. I could set it up as a pair of simultaneous equations. Alternatively, I can do a little bit of trial and error. And I think the trial and error is probably going to be quicker for this one. So if I start by saying their ages could be, it says that they're in the ratio, but their ages could either be, and we'll do the first few, 4 to 5, so they could be 4 and 5, they could be 8 and 10, they could be 12 and 15, or they could be 16 and 20. And then if I add 9 to these ratios and then see whether any of them simplify to that would work. So if I add 9 to both of those, that would give me 13 and 14. Which can't be simplified. If I add 9 to these ones, that would give me 17 and 19, which again can't be simplified. If I then add 9 to that, that would be 21 and 26, sorry. And that one can be simplified to sorry. Let me stand corrected on that. Add 9 to 15 would give me to 24, and that one can be simplified to cancel down by a factor of 3. That would give me 7 to 8. So that's going to be my actual ratio. So 12. And again, I could have done that with a simultaneous equation, but I think that one's a quicker method. Okay, simplify 2 root x plus 4. So if I square this term, and have twice the product. So 2 root x squared is going to give me 4x. Twice the product then, well, the product would be 8 root x, so twice the product would be 16 root x. And then 16 squared would be 16, and I can't really simplify it any further than that. Okay, find the exact value of a and b. So we've got ax times by x plus 4 minus 2x squared is equal to 4x squared plus bx. Okay, so I'm going to first of all compare my x squareds. So if I look at my x squareds, I can only get a x squared here minus 2, and that has to be equal to 4. So that leads to a being equal to 6. And then if I compare my x's, my x coefficients, I would have 4 lots of a, and that's going to be equal to b. So 4 lots of a is going to be b is going to be equal to 24. Nice question. Okay, find the lowest common multiple of 24x squared y cubed and 36x cubed y. So if I start with my lowest common multiple first of all of 24 and so the lowest common multiple of 24 and 36 is going to be 72. to, if I'm unsure, I can find out my lowest common multiple by doing treating it like a fraction. 24 over 36 would give me 2/3, and then I times the numerator of one by the denominator of the other. So 20, like I said, 36 times by 2 would give me 72. So 72. My lowest common multiple of x squared and x cubed is going to be x cubed. And my lowest common multiple of y cubed and y is going to be y cubed. So 72x cubed, y cubed. Sketch the graph of y is equal to 2x plus 1, showing the coordinates where it would cross the y-axis. So we're going to have an exponential graph that's going to cross the axes at 2, because when y is equal to 2, when x is equal to 0, y would be equal to 2. So we've got the coordinate on there of 0, 2. And then if we think about when the smallest that could be is going to be and so as x gets, well, our graph's going to go like that really, but we can also add on a key, a kind of a key feature. The smallest that y can actually get is when x becomes a very, very large number, and then this would kind of veer towards or head towards 0. The larger negative number that I have here, because if you think about it, it creates a reciprocal, so actually it's not going to actually get close to 0, it's going to get close to 1. So the kind of the asymptote in this direction is going to be 1. So that's going to be my very rough sketch. Okay, final row. So find the largest angle of a triangle with sides 8 centimeters, 15 centimeters, and 20 centimeters. So a sketch might help me slightly here. The largest angle will always be between the two shorter sides. So if I call that 8, 15, and 20, I'm going to be using the advanced trig formula to find out this angle here. So this I'm going to call A for now. The advanced trig formula, a squared is equal to b squared plus c squared minus 2bc cos a. I need to rearrange that for cos a. So cos a is going to be equal to, so b squared plus c squared minus a squared divided by 2bc. So I'm going to go to my calculator for this then. So I'm just going to label this. This would be A. So let's change pen colour for this. So I'm going to call that A, B, and C. Well, it doesn't particularly matter with B and C. So I'm going to say that A is going to be equal to cos to the minus 1 of, and I'll write that out fully. So B squared, I'm going to say 15. So let's do it as a fraction. 15 squared plus 8 squared minus a squared, so minus 20 squared, divided by 2 times 15 times 8. So that's going to give me minus 37 over 80. So that's going to be equal to shift cos of that answer. So I'm looking at 117.5. So I'm going to go 117.548 ... So I'm going to leave that as 117.5 degrees. Okay, simplify. So I'm going to do this in a couple of stages. So This is going to give me 2n, so my numerator is going to become 3 to the power of n plus 2n divided by, and then I'm going to add these powers, so that's going to become 3 to the n plus n would give me 2n, and then plus 2 minus 2 would cancel out, so I'm left with 3 to the power 3n divided by 3 to the power 2n, so that's going to simplify down to just 3 to the power n. Okay, find the area of the shaded segment. So for the area of the shaded segment, I'm going to work out the area of the sector, which is going to be, so I'm going to go, area of the sector is going to be equal to 70 divided by 360 times by pi times by 3 squared. And the area of the triangle is going to be equal to a half of 3 times 3, or half of 9, times by sine 70. So my area of my shaded is going to be equal to this one subtract this one. So let's tidy it up a little bit. So let's say 70 over 30 times by, not over 30, over 360 multiplied by 3 squared is going to give me 7 over 4 pi. So I'm looking at 7 over 4 pi minus 0.5 times by 9 times by sine of 70. So that's going to give me, as a decimal, so I'm going to say 4.228 ... So my answer is going to be equal to, so I want 7 over 4 times by pi minus the answer that I just worked out. So I'm going to have 1.2691 ... So 2 will go to 2 decimal places. That's going to be 1.27 centimeters squared. Okay, find the coordinates of the turning point of the curve. So we're going to have to be completing the square here. So to complete the square, I'm going to take 2 out as a common factor, and I'm saying I'm completing the square on these 2 terms. So plus 8x, and I'm going to leave my minus 19 outside for now. So that's going to be equal to x half of that squared. From that, I'm going to have to subtract 16. Well, that's going to give me 16, which is times by 2, so I'm going to have to minus 32 minus 19. So when I complete the square, I will get 2x plus 4 squared minus 51. So the turning point is going to be equal to make this bracket 0, x would need to be minus 4. And when that is 0, y would be equal to minus 51. And the final one on the warm-up sheet then. So the value of a car decreases by 10% each year. How many years will it take for it to halve in value? So if it decreases by 10% each year, in effect that's 0.9 to the power n, and we want that to be less than a half. So in effect we can kind of we could use a bit of fancy logarithms to do that, but we're not going to do that today. So I want to do, and in effect I've messed up, that should be 0.9. So I want the first time that 0.9 times by itself is equal to 0.4. So if I put 0.9 into my calculator, and then I just want to times that value by 0.9, so that would be year 2, year 3, year 4, year 5, year 6, year 7, so 7 years would be the first time where 0.9 to the power n would be less than 0.5. So let's just double check that. So 0.9 to the power of 7 gives us that as a value, and to the power of 6 gives us that as a value. So yeah, 7 is the first year where it will be less than a half. Okay, and that brings us to the end of this breakfast warm-up. I hope you found that useful. That was a very challenging warm-up. I think that's really designed to push students really well. Really appreciate that. Again, I stole this from Resourceaholic. I'll link them into the chat. Thank you very much for your time. The very best of luck for today's paper. Take your time with it. Remember, write your work, what you're going to type into your calculator, make it nice and clear for your markers. We all want you to do the best you possibly can. So good luck. I hope you found this useful, and I'll see you soon.